Welcome to another edition of ProSoft Technology video training. In this edition, we'll be setting up the ANX2 Data Highway Remote I/O Drive Module to migrate a legacy PLC5 or SLC application with a Remote I/O drive to a new EtherNet IP-based 753 PowerFlex drive without changing the PLC code. Each ANX2 module can communicate with up to 4 Ethernet IP drives, allowing users to replace their obsolete 1305 or 1336 Remote I/O drives with new Ethernet IP drives. In this video, we'll be using the ANX2's onboard web interface to configure the IP settings and to download configuration files with the Rio network configuration settings and data mapping for a quarter rack configuration, as well as the Ethernet drive configuration settings. The ANX2 is configured with 3 CSV text files, and we'll make the necessary edits to each file in order to quickly get our configuration up and running. I'll also quickly go through the steps to use the module's link local IP address.
So to begin, I'll plug the ANX2 into a switch that my PC is plugged into as well, and I'll open a browser and enter the module's link local IP address, which is 169.254.4284. Now, if the page doesn't come up for you, it could be that your computer is not set to route that address. There are a few quick steps that can fix that. First, we'll open up the command prompt and find out the current IP address of the computer you're using. And if you're using Windows 7, you need to be sure that you open the command prompt as an administrator. So once the command prompt is open, we'll type ipconfig, and what we need is the IPv4 address. This is the IP address that my computer is using right here. When you find yours, make sure to write it down. Now I'll enter a command that will tell the computer to route the ANX module's link local address. So I'll type route space add space 169.254.0.0 space mask space 255.255.0.0 space. Now I'll enter my IP address, and you would enter your IP address, space metric space 20. Hit enter, and if everything was entered correctly, you should be able to access the ANX2's webpage now. Now, once the ANX2 configuration tool opens, I'll expand administration on the sidebar and select ANX configuration. Now, here, the ANX2 can be configured to use a static IP address, or it can be configured to obtain its IP from a DHCP server. Now, in most cases, you'll want to configure the ANX with a static IP address. Otherwise, the DHCP server could assign a different IP address each time the ANX powers up. Any software that's configured to access the ANX module would have to be reconfigured accordingly. So I'll select static. Next, I'll assign a host name and set the static IP settings. It's important to use a meaningful host name because we'll be using it later. I'll enter the static IP address that I want to use. This is an address that's on the same subnet as my local network. I'll enter the net mask and gateway address. Finally, I'll change the firmware type to ANX AB drive. When all this is entered, click Submit to complete the configuration. Then click Continue to reboot the ANX with the new configuration. Wait at least 60 seconds before clicking Continue again to ensure that the reboot process has completed. Now that the IP has been assigned, the link local address will no longer work. But if I enter the new IP in the address bar, it will take me back to the ANX2's webpage. So there you have it. And as a side note, if you make changes to the module's firmware type and go through the reboot process, you'll have to clear your browser's recent cache to see the new firmware type reflected on the ANX2's main page.
The next step is to configure the ANX2 module to connect to my EtherNet drive. To do this, I'll edit the 3 text files that encompass the full configuration of the ANX2. And these consist of a main configuration file, an EtherNet definition file, and a RIO definition file. The configuration template files are available for download from the ProSoft Technology website by going to the ANX2 ABDH-RIO product page, selecting the download tab, and clicking on the Drives Files link. A link to the page will be in the description below. The template files are also stored on the ANX2's micro SD card, which can be accessed by going through the onboard web page, expanding the Automation Network tab, and selecting View Drive Templates. So once you access the drive files, you'll find a Drive Templates folder containing a list of CSV file templates for various PowerFlex drives. I'll find and select the template for my drive, a 753 ENTR. I'll copy this to my desktop, and there's also a blank templates folder that contains 3 CSV files, a blank EtherNet def file, as well as a main file and a RIO def file. Now we already have an EtherNet def file for our drive, so I'll copy the main and the RIO def files. Before we begin, I'll just mention that it's recommended to edit all configuration files in a text editor, but not to use Excel because it's been known to cause some formatting problems. So here I have a generic main definition file, and it defines the adapter racks, the baud rate, the data transfer options, as well as identifying the Ethernet and RIO definition files for up to 4 drives. As you can see, the typical baud rates for RIO networks are listed as comments. I'll just leave it at 115K. Next, we'll enter the drive definition of our rack. You have the rack number in octal form. The 00 here is just a prefix for the octal number, and then you have the actual rack number from 0 to 76 octal. Then the start quarter, then the end quarter. So in this case, I have rack number 7 with a quarter rack starting at the first quarter and ending at the first quarter. We'll set the RPI, which is the speed of your connection to the Ethernet drive. Next, we have our 2 template definition files, and these are the files that our main config file will reference in order to map the remote I/O data and the data on the Ethernet drive. The first is the Ethernet definition file for the 753 drive, so you'll copy and paste the name of the file in here, and the second is the RIO definition file for the network. Next, we'll enter the IP address of the drive that we're connecting to, and for most drives, unicast communications are desired. Otherwise, you would comment this out by adding a semicolon at the beginning of the line, which will enable multicast communications to this drive. And finally, the keyword NRAC signifies the end of that drive definition. If you have more racks to add, you would just move down to the next rack and begin entering a new drive definition, uncomment out each line, and fill in the information for the second drive. Let's take a closer look at the definition template files. The Ethernet definition file defines the drive input and output tags, and the one we're using is pre-configured for the PowerFlex 753 drive, but it's possible to create your own file if you have access to an EDS file for the device. There's a link in the description to a tech note that goes over how to do this. Now the thing to note here is the list of data points on the right side for both the inputs and the outputs. This must match what's actually coming from and going to the drive. If the actual amount of data differs from what's specified here, it will cause problems. You'll notice that every data point matches up with a name that describes what that data is. Now the actual name you use here doesn't matter. It can be anything. But whatever you do use here, this name will need to match up to the same name in the RIO def file. Now the RIO definition file contains tag mappings between remote I/O and Ethernet data. And this is also where scaling is handled if it's needed. To map your data, all you need to do is copy and paste the appropriate information from the EtherNet def file. So I'll start by mapping the inputs. And as you can see, we have a list of the bits, and we're going to paste in the properties that they correspond to. I'll start with input 0, bit 0. I'll grab the first property from the EtherNet PowerFlex template that I opened up initially and copy and paste it in. So now this property in the EtherNet drive will be mapped to that bit address in the PLC5. And now I'll just do it for the next property. And I'm going to keep going down the list of address bits and mapping them to properties from the EtherNet drive. And just so you know, you don't need to map these in any particular order. You can arrange them however you like, and you also don't need to map everything. It's totally fine to only map the data points that you need for your application. Now, for the purposes of seamlessly switching over from your Rio drive to the new PowerFlex drive, you'll want to arrange the data points to match the layout of your old Rio drive. So this is how data is mapped from the EtherNet drive through the ANX2 to the PLC on the Rio network. Now the addresses here are in octal form because the PLC5 uses octal addressing. So we go from bit 00 to 07, and then we'll go to bit 10 through 17, and so on. Once you've entered all the input parameters that you want, you can move down to feedback for input 1 and add a scaling adjustment. One of the main features of this gateway is that it's not necessary to alter or modify the original PLC program in order to replace a legacy drive with new drives. In order to achieve this, the gateway is able to change data types and perform scaling operations on parameters such as the speed reference and feedback. Feedback is a reference to the speed in hertz of the drive, and the scaling for the PowerFlex 753 and 755 drives is necessary in order for the 32-bit data from the drive to pass to the 16-bit integer form used by the PLC5. This means that the remote I/O network is passing a scaled integer value from 0 to 32,767, and it must be converted into a 32-bit real value. This is accomplished through the use of a multiplier, like what I have here. Now we can scale real values or double integers. You select what type of data you're scaling for in the EtherNet def file by going down to Feedback under Inputs, and Reference under Outputs. And you can see I have dint entered in there right now, which sets it to scale double integers. I'm working with real data, so I'll change this to real, both for feedback and reference. Now when you're doing scaling, it's important that you completely understand the nature of the data being passed and the range of values for the remote I/O data and the allowed range of values for the target EtherNet drive. In most cases, it's better to perform scaling in the EtherNet drive, but you can do it in the ANX2 if you have to. When this is done, the keyword end inputs closes out the input section. Scaling for integers works just a little bit differently, and if you'd like more information on scaling, I would again point you to the TechNote PDF that's linked in the description, as well as bundled in the Drives Files folder, along with the user manual that is available from our website. Now we'll do the outputs. So just grab the first output parameter from the PowerFlex 753 template and paste it in. And we'll go ahead and fill out the rest of this section, adding in all the output parameters that we need. At the end, for output 1, we'll enter another scaling adjustment, and this will point to reference, and this refers to the speed reference for the drive. Close out the output section with end outputs. This will complete the data mapping. Now be sure to save this file. I'm going to rename it riodef_753_drive. I'll highlight and copy the new name and then go back to the main config file and paste it in after template for the Rio side. There is one thing left to do before we download the configuration files to the ANX2. We'll open up our Ethernet def PowerFlex 753 file that we just completed. And if you go down to key, you'll see the product key for this particular drive. Now the key code consists of the vendor ID, the product type, the product code, and then your major revision and minor revision. Everything here must match what is on the physical drive. And you can get the info for your drive by going through RS links. I'm not going to worry about keying for this demonstration, so I'll just add a semicolon at the beginning of the line to comment it out, and this will disable keying for this drive. So with that, we should be ready to download our configuration to the ANX2. Return to the ANX2's web utility page, expand the Automation Network tab, and select Send Drive Template. And when the template file screen comes up, we'll click Browse, where we'll browse for, and select our Ethernet template file. Once it's selected, we'll send the file to the ANX. So far, so good. We'll return to the configuration page and browse for the Rio definition file, and we'll send it to the ANX2 as well. And with these files now in place, we can download our main configuration file. And the reason we do it in this order is so that all the referenced or dependent files are downloaded before bringing in the main file. So select Configure Rio to Ethernet IP up at the top, and browse and select the main configuration file and send it to the ANX2. If everything has gone to plan, we should get a screen showing that the configuration is in place and functioning properly. If any errors occur, they'll appear in this main window. Now all I have to do is unplug my Rio drive, attach the remote I/O connector to the gateway, and plug the 753 PowerFlex drive into the same switch that the ANX2 is plugged into. The PLC5 was already scanning the Rio drive, so now that we've switched over and everything has been mapped, it will continue to scan the Ethernet drive automatically. One quick tip for troubleshooting connection problems on the Rio network. If you find that you're unable to establish communication with the ANX2 module, you should try swapping the 1 and 2 wires on the communication line. Different vendors have them positioned differently. On the ANX2, the pin 1 is the one that's closest to the NS LED on the front of the module, and this should be connected to pin 1 on your PLC. And that is how you configure an ANX2 ABDH Rio drive module. If you have any questions or would like more information, feel free to visit our website or give us a call. Happy training!